going to do a series of videos to talk about perimeters and areas of various shapes. In today's lesson, we're going to focus on quadrilaterals, more specifically speaking, rectangles. So here are just some classic examples of geometry problems that you see regarding rectangles. So in this problem, we have a perimeter. It's given to us, it's 100, and we can need to use that information to find the value of x. So the first thing we want to do is set up our perimeter formula, which is 2 times the length plus 2 times the width. Really what you're doing is just adding 4 sides. And it doesn't matter who you call length and who you call width. So in this case, I called the base the length and the height the width. And then of course we want to go ahead and distribute. So we simplify that down a little bit. And then we want to obviously consolidate our like terms. So we're going to get 12x squared plus 16x plus 65. Now, because there's an x squared in it, I have to use my quadratic solving properties. And the only one that we know right now that's applicable to this problem would be factoring. So if we're going to factor, we need to make sure that we subtract over the 100 because you have to use the zero product property, which means that you have to have 0 on this side. So it's very important to have 0 here and then have all 3 terms on the same side. Now, normally we try to look for a GCF between 12, 16, and 35, but there is nothing that goes into all 3 of them. So we're going to have to use those numbers to find our factors. And because there's a number in front of x squared, we're going to have to do 12 times 35 and put that in the top of our x. And we're going to put 16 at the base, and we're going to try to find our magic numbers. So after playing a while on your calculator, you'll eventually find that 30 and negative 14 would do the trick. Now that we have our magic numbers, we're going to go ahead and rewrite the whole problem. But 16 is going to break into 30 and negative 14. That allows us to go ahead and group. And then we're going to factor out the GCF from each group, which in this one would be 2x, and in this one would be 5. And it's looking good. I have 6x minus 7 in both sets of parentheses, which is a fantastic sign. And then we'll go ahead and pair up our GCFs and acknowledge what the common group was. And then we don't want to forget, once we get this far, we want to take each equation or each set and set it equal to 0. And then we solve each one independently. So we'll get 2 answers in this problem. We'll get negative 2.5 and positive 7 over 6, or 1 1/6. Now normally we would go ahead and just circle these answers since both of them work for x. But whenever we're doing a geometry problem or a word problem, we just want to make sure that our answers, when substituted in, would get us logical concepts. So for example, if I substitute negative 2.5 in for x, I want to make sure that I get a positive width and a positive length. Otherwise, it's not a realistic problem. So in this case, I will just go ahead and save you the work. You will get a positive for each of these, no matter which of these you plug in. So we actually keep both answers. We don't need to reject either of them. So you'll either have a perimeter or an area problem or something along those lines. So if we're giving an area problem, it's kind of the same idea. We start up their area formula, and then we substitute in our information. And then we want to FOIL it out. And again, we're going to have to use factoring to solve this problem, or at least try factoring. So we're going to need to bring the 70 over, which will turn our 22 into a negative 48. Now before I just go ahead and start making an x and finding these numbers that make 24 times 48, it's very helpful if you can factor out a GCF. So whatever y would equal in this equation, it'll be the same thing as what y would equal in this equation. So we just divided everything by 8. And these numbers obviously are going to be much simpler to work with than the previous numbers. So we'll go ahead and make our x. We're going to do 3 times 6 and put that in the top and negative 7 in the bottom. And so we're going to find factors of negative 18 that add to negative 7, which would be negative 2 and 9. Then we can go ahead and rewrite our polynomial And we'll change our -7. We'll group them up. We'll pull out the GCF from each group. We'll regroup. And then we'll go ahead and set each of these equal to 0 and solve for y. And so I'm going to get -2/3 and 3 as my final answers. And again, because it was a geometry problem, let's just double check if both of these make sense with the picture. So if I put -2/3 in for y, I'm going to get a negative when I multiply it by 4. And any negative minus something is going to still be negative. So I'm going to have to reject the -2/3 because otherwise I would get a negative width and a negative length. And I'm going to have to go with the 3. In our next video, we're still going to be dealing with quadrilaterals, but we're going to look at squares instead of rectangles.